You know that feeling when you put something you've made, maybe writing or some work, out there, and, well, it just doesn't connect.
Yeah, crickets.
Exactly. And imagine that, but maybe over years of writing online. Reports, analyses, code even. You hope it connects, but silence.
Oof. Yeah.
And that little voice starts up, right? Am I just doing this wrong? Should I even bother?
Oh, absolutely. That self-doubt is such a common thing when you feel unseen.
Yeah.
And in the story we're looking at, this person feeling that exact way
Yeah.
decided to try something different.
Yeah.
Got feedback from ChatGPT on their LinkedIn intro.
Ah, okay. And what happened?
Well, the AI was surprisingly blunt. It said something like, it reads like a well-written resume, but it doesn't reveal your identity.
Wow, just like that.
Just one sentence. But for the writer, it was like, bam, a real moment of insight.
A light bulb moment triggered by code.
Pretty much. Suddenly realizing that this professional image they'd built was actually hiding them. A genuine insight sparked by AI.
Okay, that's fascinating, because the AI delivered this insight, but did the AI change?
And that's the crux of it, isn't it? That's the deep question we're diving into today. The human had this profound shift from the AI's feedback.
Right.
But the AI itself, does it learn or change from giving that feedback? Why this asymmetry?
So the human transforms, gets this new understanding, but the AI, it just kind of stays the same. It generated the response, but didn't internalize the interaction.
Exactly. It doesn't seem to evolve from that specific exchange like we do.
Okay. So for this deep dive, we're looking at an article that tackles this specific thing, this crossroads between human insight and what AI can or maybe can't do.
Yeah, our mission here is really to unpack this difference. We want to explore, what would it even take for an AI to get something like insight? And why is our understanding so fundamentally different right now?
So the article starts with defining insight itself, calls it enlightenment in a human context.
Right, and it defines it as a deep human realization. You suddenly grasp a truth, an essence, a new direction. It's a powerful feeling.
But then the article immediately says, AI can't do that. Not really.
No, not in the way we meet it. We get these aha moments, these shifts, often sparked by something external, like that AI feedback example. But the AI doesn't feel the impact it has. The article calls it asymmetric. We gain insight through the AI.
But the AI itself is unchanged. Like, the flashlight doesn't see the beam it casts.
That's a great way to put it.
Yeah.
The giver of enlightenment, in this case the AI, stays unenlightened. It's a paradox.
Okay, so let's get into that contrast more.
Yeah.
How humans change versus how AI just repeats.
Well, the article lays it out clearly. For humans, change can spark from just one thing, a single word, like that LinkedIn comment.
Right.
And that change involves reflection, emotion, that internal click of insight. It's driven by meaning, by our own internal world. Autonomous.
And AI.
AI generates patterns.
Right.
It's trained on massive data sets. Its memory isn't like ours. It's not tied to emotion in that associative way.
No feelings, no real self-awareness.
Exactly. So for an AI to change its core behavior, it needs external retraining. Someone has to feed it new data, adjust the algorithms. It's data-driven, imposed from outside.
So unlike us potentially having a huge realization from one event, AI needs that pattern shown, what, millions of times?
Pretty much, yeah. That's a fundamental difference in learning.
Yeah.
And maybe that's why AI can't have that aha moment. It doesn't work that way.
Which brings us to the really interesting bit the article explores. What would AI need technically to even simulate something close to insight?
Right, and we're not just talking about giving a smarter answer. We mean changing its actual internal learning setup, its architecture.
So what are the candidates? The article mentions a few key areas. First one is meta-learning.
Meta-learning, yeah. The article describes it as the AI learning how to adjust its own learning strategy, maybe based on just one new piece of info.
Okay, that does sound closer to how we adapt, right? Learning how to learn, almost.
It does. And it connects to other ideas, like in-context learning, which some models like GPT already do a bit of using the current conversation to refine responses. And also continual learning, the idea an AI could learn new things without forgetting the old stuff, which is actually a really big hurdle right now.
Right, the catastrophic forgetting problem.
Exactly. And there's also neuromodulation mentioned, trying to mimic how our brain chemistry adjusts learning flexibility.
Okay, so learning strategy is one part. What's next? The article talks about the hardware itself, neuromorphic computing.
Yes, neuromorphic computing. This is about building computer chips that are structured more like the brain. Parallel processing, state-based operations, that kind of thing.
So if AI needs to learn more like us, maybe it needs hardware that works more like us too.
That's the idea. Some research talks about using these for energy efficiency, event-driven processing, often with things called spiking neural networks, SNNs.
Spiking networks, like mimicking neuron firing.
Sort of, yeah.
Mhm.
More biologically plausible. And newer stuff from 2024 explores using special materials to achieve one-shot learning really fast from minimal examples like humans sometimes can.
Wow. Are there actual examples of this hardware?
Oh yeah, the article mentions Intel's Loya chips, memristors, IBM's True North, even physical neural nets. The goal is often to combine processing and memory, like the brain does, instead of keeping them separate like in traditional computers. Makes certain kinds of learning potentially much more efficient.
Fascinating. Okay, and the third area the article mentions feels really key, simulating emotion and memory.
Absolutely crucial, because that's where so much of human insight seems rooted.
Right.
So the article points out that while AI can mimic emotions, think chatbots saying, "I understand your frustration," it doesn't have them. Work at MIT Sloan highlights these limits.
It's just mimicking patterns associated with emotion words.
Exactly. And on memory, there's some interesting research noting structural similarities between brain receptors important for memory and MDA receptors and AI models like transformers.
Oh, how so?
It relates to how they handle information over time, sequences. But, and this is the big but, the article stresses AI fundamentally lacks our kind of memory, that associative, emotionally charged recall.
Yeah, my memory of my graduation isn't just data point X. It's tied to feelings, smells, the whole context.
Precisely. AI memory is more like RAM, easily overwritten, no inherent personal meaning or emotional tag. And that lack of emotional associative memory is likely a huge barrier to AI having genuine insight. Those aha moments often connect disparate ideas through just such links.
Okay, so the article dives into some specific research supporting these ideas.
It does. It summarizes a few key studies. First, Stenning and colleagues in 2024 looked at neuromorphic systems.
The brain-like hardware ones.
Right. They found these systems are good at learning fast. From few examples, they adapt quickly, which is impressive. But
Right.
they still don't show that meaning-driven internal shift. They adapt, but they don't seem to get it in the human sense. No deep understanding.
Okay. Then there was Wu and others in 2022.
Yeah, they explored something called global local meta-learning,
Mhm.
trying to combine different learning rules like Hebbian learning, neurons that fire together, wire together, with standard AI training methods like backpropagation,
Legolby.
more flexibility, trying to get AI learning to work across different scales, more like how humans seem to manage it.
And one more. Schumann and colleagues.
Right, also 2022.
Yeah.
Their work focused on a roadmap for neuromorphic algorithms. They really emphasized energy efficiency and event-driven models only processing when needed, like neurons. They discussed spike-based learning and the practical challenges of mapping AI onto this new hardware.
So lots of work trying to bridge that gap, but it's still a huge gap. The article uses a visual summary to really hammer home the differences, right?
It does, yeah.
Yeah.
It's a stark comparison. Like for transformation, humans can be totally reoriented by one experience. AI needs massive retraining.
And memory.
Humans, associative, emotional, AI address-based, like a file location, and easily lost.
Mhm.
Volatile.
Insight.
Humans.
Main.
That meaning-based internal shift. AI just absent. Humans, present data. AI can mimic, but absent fundamentally.
And lastly, energy use.
Humans can have a huge internal change from a tiny input, that one-sentence example. AI usually needs lots of computation, repeated operations, even if they're efficient ones.
Oh, wow. Okay, so the conclusion of the article really drives this home.
It does. It comes back to that core idea.
Yeah.
Humans move through the world based on meaning.
Mm.
We interpret, we understand.
While AI moves through calculation, processing data according to rules.
Exactly. So human insight